Welcome everybody to the Introduction to Computer Science, episode 3. So in previous videos, we talked about these two subjects, that memory holds data that isn't being processed in the processor, otherwise known as the CPU. And we've also talked about binary, how binary is zeros and ones. And this is how computers represent data. And the zeros and ones are just wires that are on or off. So let's use these ideas to talk about memory more in detail. But first, let's remember what every computer has. So every computer has processing power, and this comes through the CPU. Every computer has some form of memory, and then it also has input and output. So we can use the ideas that we discussed in previous videos to zoom in on the picture of memory. So memory, we know, stores data, and data is just wires that are on or off. So using this, we can say that memory is just wires that are off and wires that are on. Okay. So next, let's talk about the two types of data that there are. So there is what's known as primary memory, and there's also what's known as secondary memory, if I can spell it. There we go. So we're going to use an analogy to describe how these relate to each other. And we're going to use the analogy of a business. So a business, and the business will be our computer. So any business has a boss, otherwise known as CEO, and then it also has some secretaries or a secretary, and then it also has workers. So we're going to denote the workers as the secondary memory. We're going to say the secretaries are the primary memory, and the CEO is the CPU, because the CPU is the thing that's actually doing the processing and the work. Okay, so in a business, workers pass information to the secretary, and then the secretaries pass it to the boss. And it's the same in a computer. Secondary memory passes information or data along to the primary memory, and the primary memory it's closer to the CPU. And this is true in a business. Secretaries are usually located right by the CEO's office or whatever. And then it's true in computers too. Primary memory is a lot closer to the CPU, so it's going to be faster to get the information to them. So secondary passes to primary, and primary passes to the CPU, and then this can go backwards. CPU can pass back to the primary, and primary back to secondary. So the most typical form of primary memory that we see in modern day PCs is what's known as, oops, that's not the color I want. Let's go with green. So primary memory, the typical example is RAM. RAM stands for random access memory, and we'll talk about that way more in detail when we talk about computer architecture, but that's quite a ways down the line. The typical example of secondary memory is a form called HDD or SSD. So HDD stands for hard disk drive, and SSD stands for solid state drive. So the only difference here, and it's an important difference, but it's really the only difference, is that the SSD is faster than the HDD. And I found a number online that just says SSD is usually 5 times faster, but I don't know if that's true or not. Just know that it's faster than the HDD. Okay, so now that we know the relationship between primary and secondary memory and the CPU, and we have an example of each, let's talk about size. Whether you believe that size matters or not, for humans, in computers, size does matter. Okay, so we know that memory is just wires. So the most basic or smallest form of memory we have is just a wire. One individual wire. And this wire can be either on or off. And this is what we call a bit. So this is how we quantify memory. We're quantifying it based on how many wires there are, and we're using these words bit, and then the next one is byte. So a byte is just 8 bits, and we denote these two words as a lowercase b and a uppercase b respectively. And then from there we just go up in size. So we're using prefixes now, so I'll just write the prefix. So we have a kilobyte, which is 1,000 bytes. We have a megabyte, which is 1,000 kilobytes, which is 1,000 bytes, so 1,000,000 bytes. And then we have what's known as a gigabyte, and a gigabyte is 1,000,000,000 bytes. This is the most common size we see in computer memory. And then the last one we'll talk about is a terabyte, but the sizes can keep going from there. But typically in PCs, we just see it up to the terabyte. Okay, so now we know about size and we know the relationship between the two types of memory. Let's talk about this a little more in detail and bring the two ideas together. So in RAM just looks like a stick of gum, and it has little chips in the bottom that are usually golden. So this is RAM. We see, so this is the most typical example of primary memory. So this is in general primary memory. But usually we see primary memory having a size of anywhere from like 2 gigabytes up to 32 gigabytes. But in most computers it's anywhere from like 6 to 16, because that's the size that you need to have your computer running functionally. There's a video where this guy takes 2 terabytes of RAM and sees how many Chrome tabs he can open. I'll link that in the description because it's kind of interesting to watch. And 2 terabytes is an insane amount of RAM. Your CPU isn't going to be able to keep up with that amount of information being passed along. And then the second form of memory is the secondary memory. And this comes in forms of disk drives. So in Windows, they're named according to letters. So we have like the C drive, the D drive, and all that, but the C drive is the most popular. And secondary memory can range anywhere from 256 gigabytes to 2 terabytes. So we can see that secondary memory is a lot larger than primary memory. And this makes sense because with our analogy, the secretary, there's only going to be a few secretaries for business. And the secretaries, like we said, are closer to the CEOs, so they can pass information. But if there's too many secretaries, then the CEO, the CPU, isn't going to be able to keep up. And similarly, there's a lot more workers that pass through the secretaries, and that's why we see a bigger size for the secondary memory. So we know now that the memory is just a bunch of wires in like a grouping. But we can break these wires down into sections on their own, and these are what's known as files. So files are simply groupings of the memory. Yeah. So this could be like one file, this could be another file, this could be another file. It's just a section of the wires in the memory. Okay, so that wraps up this episode. Now that we know a little bit more about memory and how it works, we can talk about programs.